Hello, calculus fans. Let's evaluate the limit as x approaches infinity of arctangent of x over x to the minus 1. Now, I'd like to point out the wrong thing to do here is to just apply L'Hopital's rule. Now, this looks like the right thing to do to say, well, let's just differentiate the top and the bottom and do a little bit of algebraic simplification. The trouble is that the limit of the top is pi over 2. And that means L'Hopital's rule doesn't even apply. You can't use L'Hopital's rule on this. Remember that L'Hopital's rule can only be applied to an indeterminate form of type 0 over 0 or infinity over infinity. Now let's go back and make sure that we know why the limit as x approaches infinity of arctangent of x is pi over 2. Let's take a look at the graph of y equals arctangent of x. All right, this is what the graph looks like. The graph of arctangent of x has a horizontal asymptote at y equals pi over 2 and another one at y equals negative pi over 2. And I think it'll be useful to have this graph in mind going forward. And knowing that the arctangent function has horizontal asymptotes. Those horizontal asymptotes lead us to the understanding that the limit as x approaches infinity of arctangent of x is equal to pi over 2, and the limit as x approaches minus infinity of arctangent of x is negative pi over 2. So the right approach is to say this, that the limit as x approaches infinity of arctangent of x over x to the minus 1, well, we can rewrite this by taking that x to the minus 1 and moving it back up. And now that piece, the x, goes to infinity, and we know that arctangent goes to pi over 2. So we have a very large number multiplied by something that's close to pi over 2. That limit is going to be infinity. Okay, that's all for now.